AquaShield is a new range of non-permeable universal fittings that are an ideal solution on brownfield sites to connect different barrier pipe systems.
My name's Chris Yates. I'm Senior Design Engineer working at Viking on AquaShield. Part of the testing of the AquaShield project is that we passed the BS 8588 resistance to permeation of contaminants test. The reason Viking chose RINA is because they're well known within the industry. They've been around for a long time and they're experts in the testing and analysing of hydrocarbons.
So I'm Ben Hickman from RINA, and I'm heading up the part of the business which looks after the testing of pipework systems. So RINA is a global business, and the UK part of the business is very wide-ranging, covering testing and consultancy services from electrical through to mechanical through to materials. So as far as the UK business is concerned, there are two main timelines that have come together in the history of RINA. One of them is the UK part of the business, which was established in the 1920s as the Electrical Research Association here in Leatherhead. And the other part of the business is RINA, the global business, which is headquartered in Italy. The company was established in the 1860s with a marine certification background. So there's a tremendous diverse mix of engineering come together to form the business today. The test program is quite a long and involved one. The main part of it is a 60-day immersion in a saturated fuel vapour atmosphere. That's then followed by a 72-hour immersion, after which the water samples are taken from the pipes and then subjected to a series of further tests. The aims of these tests are to demonstrate compliance with a part of BS 8588, specifically the resistance to permeation of contaminants. One of those tests is an odour and flavour test, where a panel will sample water recovered from the pipework, and the aim of that is to detect any hydrocarbon content within the water. When assessing the water samples, there's a requirement that 2 or more panellists should detect no discernible odour or flavour within the water. And then the final part of the test programme is an analytical Gcms test, which is a gas chromatograph mass spectrometer. In that test, we will actually quantify the amount of hydrocarbon present within the water.
So we take the water sample, we heat it up to generate volatile materials, and we take the headspace above the water, which contains the volatile materials, and we inject that gas into a gas chromatograph which has a mass spectrometer attached to it, and this separates the volatile materials. We get a chromatogram which we can look at the peaks and identify that with the volatile material that's present. You're looking for toluene and isooctane, so the fingerprints will be very different for those two chemicals. And we also get a retention time, so they come out of the machine at different times, so we can use that retention time to identify the material as well.
There's a requirement when assessing the chemical analysis results that there shall be no more than 100 micrograms per litre of dissolved hydrocarbon content within the undiluted water samples.
By independently testing at RINA to BS 8588, the results will be taken by WRC to give us the accreditation to confidently take the product to market.